Hello everybody, welcome back. Today we are going to do a simple little kit build. I saw this over at RP Electronics and thought it would be fun to get it for my weekly gaming sessions. My friends and I play a system that uses d10s for the gaming system, and what this thing does is you push a button, it spins around, and then randomly lands on one of 10 LEDs. So I thought it would be fun to play with around for our gaming nights. It's a fairly normal setup. We've got a decade counter here, which is going to provide our logic highs for one of 10 LEDs. There's a hex inverter here that I have absolutely no idea what they're using it for. A hex inverter is basically 6 NOT gates, which make it so that if you put a logic high into a NOT gate, it's going to have a logic low on the other side. And if you put a logic low on the input, you're going to get a logic high on the output. I'm looking at the schematic here, and they've just got 3 of the inverters in series, which is just going to take the signal from the one side and flip it around, but it flips it 3 times. And then they've got, in another part of the circuit diagram, that they've got 3 of the inverters in parallel. I have absolutely no clue why they would be doing that. I'm sure there's a good reason for it. But yeah, that's an interesting application. I don't understand why they would do that. Anywho, so fairly straightforward. There aren't any components that we haven't seen before. We've got some electrolytic capacitors. We've got a little ceramic capacitor. This is probably a 4148. That's a Zener diode, I believe. So that's going to be some sort of voltage regulator there. We've got a series of resistors here, which actually one of the interesting components in the resistors here is this one, which just has one black stripe, which means that this is actually a 0 ohm resistor. It's a very curious component. They typically use these when they needed to have a trace going from one point to another, but they couldn't actually make those traces go. Let's actually see here. This is for R7, so R7 is over here. Basically, they needed a trace that went from here to here, but the board wouldn't let them do it, and it's not a dual-sided board, so we're just using the 0 ohm resistor to create a trace between these 2 paths. So that can be sometimes a shortcut. If you don't want to go to the added expense of doing a 2-layer PCB, you use 0 ohm resistors for your traces. Anyway, so I'm just going to hop into time-lapse mode here, throw this thing together, and we'll pop a battery in it and see what it looks like on the other side. So we'll see you in a few minutes. Alright, and we're back. That went quite smoothly. Getting the power leads soldered in was a bit of a challenge, but aside from that, everything was good, and as you can see, you click the button, the lights spin around, and they gradually come to a stop. And in that case, I would have rolled a 1. Now, the kit didn't actually come with a blue LED. I just decided to throw one in for 10 just because I could. Typically it has 4 green LEDs, 4 red LEDs, and 2 yellow ones. But yeah, there we have it. It's a fairly simple, easy circuit. A quick build and kind of a neat little, totally useless, but it'll be fun to play with little circuit there. So thanks for joining me today. We'll put a link to subscribe over there, and we'll put a video that you may find interesting there, and we'll see you all in the next video. Bye-bye.